Digital electronics collectors and restorers. Here's an interesting one on my bench. This is a Stark TA-1 multimeter, and picked it up at a flea market. I just wanted you to see the complexity of this. Here's a digital one that I often use, that has actually very similar functions. This one was kind of unique. They first came out in 47, 48. A very common meter in southwestern Ontario. They were made in Toronto by Stark Electronics. And it does quite a few things. It does, besides ohms, volts, DC, volts AC. It has a milliammeter on it. It has a capacitor checker. It actually gives you a reading through quite a wide range of scales. I'm just going to show you the front of this. I don't have it all together yet, but I thought you should see some of the components. These turrets and switches are all heavy duty. I think this thing's had quite a bit of use. Everything about it is solid, but because of age, things start to go wrong. One of the interesting features on it, it has an RF probe for AC circuits. So you can actually look at the AC waveform between circuits or in the IF stage of a radio or TV. This would have been the kind of meter that there were a lot, at least in this area, a lot of servicemen came back from World War II, got into radio and TV. And this would have been what they would have been using back in the day, late 40s through the 50s, maybe for decades. A few things to bring it up to date and get it working. First of all, 3-prong cord, because it's a metal unit and you're dealing with AC voltages from 5-tube series radios that don't have a transformer. Every cord and plug on this was in bad shape. This is actually a USB cord, and it needs to be shielded. It needs to have 2 conductors inside of it besides the shield. So one is for the actual reading, the other is for ground, and believe it or not, there was a tube in here, a 9006 tube. Some later ones a 6AL5, and it was kind of problematic having a tube in here because it didn't take much to finish it off. I actually put this is a USB cord. I have lots of these. They're shielded and they're tough. So I use that, and I just use an IN4007 diode in place of the tube to get it working. If you wanted to do voltage readings, AC below 3 volts, you could just take the 2 screws out and swap in a germanium diode. You can actually stick the ends of the diode. There's a tube socket in here, 7. I should have left it open, but to make the video longer. There's a 7-pin tube in there, and you can just stick it in between pins 5 and 2. So that range is all working. It has, that one from the factory was attached like that. The DC volts used one of these old microphone connectors, this style here, and I hooked up a probe, created a new probe for it, and it was intermittent. This thing just wasn't making a good connection no matter what I did because of oxidation, etc., etc. So I actually made a 1/4-inch phone jack, nice and easy, didn't have to file or anything. So then you have a DC probe. Of course, you'll need a ground. So I created, this is made from a pair of Simpson 260 leads that were a little bit newer, but they're the same rubberized covering. So there you have a ground. You can use that cable. And then if you want to do ohms and capacitors, you use the other red cable. This is what the set would have been like from new. And I tested capacitors with it. It's actually very accurate. There are some things you can tweak inside of it, but it's actually very accurate. It has quite a few ranges too. There's actually 7 different ranges. The milliammeter works. Something I don't use that often. I usually just take a voltage reading and then calculate the current from that. Takes a number 47 pilot lamp. So made some new cords up for it. I'll just talk a little bit about the interior issues. Bring it around again. See, there was that probe, it just banged on the table. It had a tube in it, it might break it internally. Anyway, why they're 2D batteries? There was a battery clamp here for 2D cells that was badly corroded. It had leaked. So I had to get rid of that and just put in a plastic holder. And it's actually for bias in the metering circuit. You have to have this meter plugged in to use it. One issue, the biggest issue of any internally, there's two 6x5 GT rectifier tubes. These are problematic. They come up every once in a while in something. And both of them on my tester, on my ICO tester, showed cathode to heater shorts. Bit of a problem with these. Not good. In particular in the power supply, it will damage the power transformer. So here's the thing. I had several 6x5s. Some of them new in the box. Every one had a problem. None of them were quite right. One of them didn't show short, but then I ran the meter and the needle's going tick, 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 tick. What can you do? Well, here's what you do. You take a base. I'm just going to pull these out. These really clamp in. Okay. Well, this is a 6x5, and basically, right here, there's two IN4007 diodes in there. And so you have to very carefully break the glass envelope, unsolder leads from the pins, put in two IN4007. Once I did that, the meter perked right up. No weird intermittent issues, no arcing inside the rectifier tubes. And here's the thing, if you buy this meter from me down the road, that's really tight. You're going to have to, or you don't have to do anything actually, you can just use it the way it is, or you can just pull these substitutes out and put in your own 6x5s. I don't believe in soldering stuff like that permanently into the circuit. Try and maintain its originality. I had a small filter capacitor replace that, a couple resistors that were way out of whack. So that's about it. I'm going to put it together, try some reads on it, repainted the metal case. It was in pretty rough shape, steel case, but used some Tremclad hammer tone on it after vigorous sanding, and we'll see what we get. Thanks for watching and listening.